Welcome to this M1 video on modelling with statistics. So like I said in the previous video, I don't feel like there's anything really that new in the last video and in this video and the next video. Okay, it's like stuff that we have definitely touched on with forces and friction previously. The only real difference is that in this section everything's always in static equilibrium. Okay, so the forces or the objects aren't moving, so everything's in static equilibrium. So that is the big difference, and we're starting to deal with a bit more with string and stuff, cables and stuff like that, and tension and ropes and things. So that's really the only difference. And you know, the modeling one now is just going to take it just up a little bit of a level in terms of difficulty. But again, you know, I think you'll see that they're not too difficult. Have a look at me going through the examples and then have a go at the questions yourself. I'm sure everyone will be fine with these once you get through this video and the next video. I think you'll all be very good and competent with dealing with forces. So here we have the example. A smooth bead B is threaded on a light inextendable string. The ends of the string are attached to two fixed points A and C. On the same horizontal level, the bead is held in equilibrium by a horizontal force of magnitude 2 newtons parallel to CA. So it's there parallel to CA. The sections of the string make angles of 60 degrees and 30 degrees with the horizontal. Find the tension in the string and the mass of the bead. So the tension in the string is going to be these two here, and the T's are going to be the same, okay, because it's a light and extendable string, so these should have the same tension throughout. Now, what I want to do here is resolve, and we're going to resolve horizontally first of all, I think. Now, I'll just put my forces on the bead. So the bead is, we don't know the mass, so that's going to be mg. And then going horizontally, now this is going to be, 60 degrees, isn't it, using the Z angles. So this one horizontally will be T cos 60, and going up will be T sine 60. And then the other T will be going across, and this will be 30 degrees. So this will be T cos 30. And going up will be T sine 30. The 2 newtons is already going horizontal, and the mass is just going vertically down, so it isn't affected on the horizontal. So when I do this, we've got T cos 60 plus 2 equals T cos 30. So cos 60 is a half. So we've got a half T plus 2, and cos 30 is root 3 over 2. Okay, and root 3 over 2 is bigger than a half. So taking it to the other side, we got root 3 over 2 minus a half T, and that equals 2. So 2 divided by that is 2 plus 2 root 3, or 5.46 newtons to 3 significant figures there. And that is basically A done, isn't it? Find the tension in the string. Now we move on to B. We want to find the mass. So for this, we're going to resolve vertically, and that's going to give us t cos 60 plus t sine 30 equals mg. Okay, so I've got my t now, and I'm going to store this value as a so I can use it. Oh, I'm sorry, I've written cos 60 in there. That should be sine 60. Okay, so t times sine 60 plus t, which is my a, sine 30, that equals mg. So mg equals 4 plus 2 root 3, divide by 9.8, and we get that the mass is 0.762 kilograms to 3 significant figures. Now, sometimes they ask questions to do with, like, afterwards, like a part C, you know, what does the smooth mean on this bead? And then you'd say, you know, obviously that means that there's no friction and stuff like that. So there is always like a third part sometimes on these, or an additional part, which just asks you, you know, to do with the question, what there might be, you know, what modeling assumption has affected your calculations, kind of thing, and it might pick something like the smooth bead in this case. So just be aware of those. But that's the first example. Let's have a look at one more. So here we have a mass of 5 kilograms resting on a smooth plane inclined at 30 degrees. So we can see it down here. The mass is attached to a cable and passed over a smooth pulley as shown. So the pulley is smooth, so there's going to be no friction. And the surface is smooth, so there's no friction on the surface as well. The cable carries a mass of 2 kilograms freely suspended on the other side. So if I just put some values on, this is 5 kilograms, so 5 G newtons going down. This one's 2 kilograms, so 2 G newtons going down there. Now, the masses are modelled as particles and the cable as a light inextendable string. There is a force of P newtons acting horizontally on the 5 kilogram mass. So it's probably acting like this. However, I'm going to put it this side because I find it easier to do my calculations there. Just sort out this pointed bit. So that's P newtons. And then this is going to have a normal reaction R up there. Okay, tension in the string or the cable there. And now I think we've got everything, just need to resolve. Okay, the system's in equilibrium, find the magnitude of P and then find the normal reaction between the mass and the plane. So I'm just going to switch colours for a moment. So I'm going to go to red to deal with my P, and I'm going to go perpendicular and parallel to the plane. So this is P cos 30 going up because this angle is 30 degrees. And then this will be P sine 30. And then looking at the 5G mass, this is going to be 5G sine 30. No, it's not. It's going to be cos 30, isn't it? And then down the slope would be 5g sine 30. Okay, so now I've got a lot of my information. Okay, now I can go ahead and consider some of the weights and the masses. So I'm going to start off by considering the 2 kilogram mass. Okay, and when I resolve vertically there, I get the T equals 2g. Okay, and that's going to help me then when I move on to the 5 kilogram mass here. So next I want to consider the 5 kilogram mass, and I'm going to resolve parallel with the plane. So going down the plane, we've got 5g sine 30, and there's no other weights or masses or forces acting down the plane. And then up the plane, we've got p cos 30 plus t. Now, t I already know from this previous one here is 2g. So p cos 30 plus 2g, and this is 5g sine 30. So now I can rearrange and solve for p, and p is 5.66 newtons to 3 significant figures. Now, as always, I'll store that as A. I always store A at the beginning of the question, and then B and C and so on if I need more going throughout. So we've done part A, now we need to do part B. We need to find the normal reaction. So for that, we're going to continue considering the 5 kilogram mass, and this time we're going to resolve perpendicular. So that's going to give me that R is equal to P sine 30 plus 5g cos 30. Now I know what P is because I've just worked that out. So keeping that in my calculator, times by sine 30 plus, and now we've got 5 times 9.8 times cos 30. And that gives me that R is 45.3 newtons. And that again is the 3 significant figures. So hopefully you were able to follow this and see what was going on here. Okay, it can get quite confusing with all of these forces on here. Sometimes, you know, I might draw an extra diagram and then omit the original ones and just leave on the new ones. But, you know, it's up to you how you go about doing it, but it's very important to draw a diagram. Okay, so there it is, 2 examples. And like I said, I don't feel that this is too difficult, but the questions are getting a little bit more interesting. So that time in the video as usual, if you are not a subscriber, please consider hitting that subscribe button. If you've found the video useful so far, hit that like button. And if you're willing and able to help me out financially, smash that join button. Otherwise, let's look at the questions. So I've got 4 questions for you today. They're all past paper questions or based on past paper questions. I've just picked out 4 of them. So pause the video now to have a go at these 2. And pause the video now to have a go at 3 and 4. Welcome back. Okay, should we have a look at the solutions to these questions? So I did kind of cut the question down a little bit when I was writing them, just took the information that was already in the diagram out of the question to make it a little bit smaller, as some of these questions were quite large. Anyway, let's get on to this. So we've got tension going in these directions, and we need to find the tension in the string. So for this, I think we're going to resolve both vertically and horizontally. Now, to find the tension in the string, we'll probably resolve vertically. So I'll do it in red for this T here. So this T, now this angle here is 30 degrees, isn't it? Because it's a Z angle, so this is T cos 30. And going horizontally will be T sine 30. And then in purple for the other T we'll have one going down and one going across. So 60, so this angle here is the 60 degrees. So T cos 60 is going down and T sine 60 is going horizontal. And then the 2 newtons and the mg newtons will stay the same. Now, I did say I was going to resolve vertically here, but if I resolve vertically, I've got T's and I've got M's, so I can't resolve vertically to find the tension. I need to look at the horizontal ones. So we've got T sine 30 plus T sine 60 equals 2. So sine 30 is a half and sine 60 is root 3 over 2. So that means that T is 1.46 newtons to 3 significant figures, and I'll store that as A. And that was obviously finding A. Finding B, now we can resolve vertically, and we have T cos 30 equals mg plus T cos 60. Okay, so rearranging, mg will be 0.5358 and so on, then divided by 9.8, and we get that the mass of the bead is 0.0547 kilograms to 3 significant figures, or this would be like roughly 55 grams, which sometimes they might ask for, like, you know, oh, it is actually, I didn't read that bit, to the nearest gram. So 55 grams is to the nearest gram. So it's not O, that is equals. There we are. So that's question 1 done for you. Let's move on to number 2. So again, I've slimmed down this question. I've done it to all of them, so I won't repeat it again. But we've got a particle of weight 2 newtons. And it's going to have a normal reaction there. Rests on a smooth horizontal surface and remains in equilibrium under the action of 2 external forces as shown. And then tan theta equals 12 over 5. So I can draw a little triangle here for theta. Tan is opposite over adjacent. So that'll be 5 squared plus 12 squared, and then square rooted will give me 13. So now I can say that sine theta is 12 over 13 and cos theta is 5 over 13. And using these fractions will just make it easier than putting a decimal number in for theta. But you can work out theta and just substitute it in if you wish. Anyway, let's look to resolve P. That's the one we need to resolve. So think of it coming off the other side. It's going to be going down and it's going to be going horizontal. So this is going to be P cos theta and P sine theta. So to be able to find P, I need to resolve horizontally, don't I? So that is P cos theta equals 1. Now cos theta is 5/13. So P equals 13/5, or 2.6. Now let's resolve vertically so that we can find out what R is. So R is going up, and that is equal to 2 plus P sine theta. So it's 2 plus, and P is 13/5. Times, and sine theta is 12/13. So that's going to be 12/5, which is 2.4, plus 2 is 4.4 newtons. And that's question 2 done. Let's move on to number 3. So we've got a particle of 2 kilograms rests in equilibrium on a smooth inclined plane. So that's this one, 2g there. Tan theta equals 3/4. So tan theta equals 3/4. So this one's going to be 5. So sine theta is opposite over adjacent, and opposite over hypotenuse, and cos theta is adjacent over hypotenuse. So that's those two done. The particle is attached to a light inextendable string passing over a smooth pulley as shown. The other end is attached to a 5 kilogram weight mass. So 5g newtons going down. That's tension there. That's tension there. This is R. So all we really have to do is we have to deal with this 2g weight here. So I'll go into my red pen. So this angle here is theta. So 2g cos theta is there. And then going down will be 2g sine theta there. Okay, so that is that. Now we have to find the value of f. So we don't actually need R in this case. So first let's consider the 5 kilogram mass. Okay, so that then resolving vertically we get T equals 5g. So that gives me T straight away. So now we consider the 2 kilogram mass. And for this now we can resolve parallel to the slope. So going up the slope is T, and then going down the slope is F plus 2g sine theta. And of course we have everything now except for F, don't we? Because if I just get rid of that a second, because T is 5g, F plus 2g, and sine theta is 3/5. So we have everything except for F. So we can rearrange for F, and F is 37.24 newtons, and that is exact. Oh, I read this wrong then. Find the value of F is B. So this bit was just like B. I actually missed out A, find the magnitude of the normal reaction. So I'll do that now. So that is still considering a 2 kilogram mass, but we're going to resolve perpendicular. So that would be R equals 2g cos theta. So that's 2g times 4/5, which is 15.68 newtons exactly there. So that's part A done and part B done. So sorry I did them the wrong way around. I just missed out part of the question there. So C is state how you use the fact that the pulley is smooth. So the pulley being smooth means no friction between the string and the pulley, and it means that the tension is the same either side of the pulley. Because if we include friction might be acting in one direction, a direction that this is potentially going, which would mean that then the tension on either side of the string or either side of the pulley would actually be slightly different. Okay, so having a smooth pulley, and all of M1 is always a smooth pulley, but having a smooth pulley means that the tension remains the same both sides of the pulley. So that is number 3 done. Let's move on to the final question. Okay, number 4. So we've got a particle of weight 20 newtons. So 20 newtons acting straight down. Rests in equilibrium on a smooth inclined plane. It is maintained in equilibrium by 2 external forces as shown. Find the magnitude of the normal reaction. So we want to find R. So we technically don't have to find P, but we do have to find P to be able to find R, don't we? So let me resolve P first of all. So P is going to be up here and this way. So up the slope will be P cos 30, and then this one will be P sine 30. And then I'll switch to purple when I do the 5 newtons. So this will be going down the slope here. Now, this angle, so it looks like it makes a Z angle there. So this angle here is 45 degrees. So that means going down the slope will be 5 cos 45. And then going up here will be 5 sine 45. Although being 45 degrees, it doesn't really matter because sine 45 and cos 45 are the same. Now dealing with the 20 newtons. So we're going down and we're going perpendicular. So again, now this angle is 45. So this is 20 cos 45. And 20 sine 45. But like I said, with the 45 ones, it doesn't really matter. So first, let's resolve parallel to the plane. So going down the plane, we have 5 cos 45, and we have 20 sine 45. So those are the two going down the plane. Then going up the plane, we got P cos 30. So from this, I can rearrange and find P. And P is 20.4 newtons to 3 significant figures. And as always, I'll store that as A. Now we'll resolve perpendicular to the plane. So going up, we have r plus 5 sine 45, that's in purple, plus p sine 30, which is the one in red there, and that equals 20 cos 45, which is in green. Now, since we've worked out p, we can go ahead now and rearrange for r, and we get that r is 0.400, it goes 3944 and so on. So let's just write it as 0.4 newtons to one significant figure there. And that is the final question. So hopefully you found this video useful. Okay, again, now you can go and practice some more of these questions now, just to build up your confidence and your skill. The more different questions you can experience in practicing, then the less likely that you will be surprised when it comes to the real exam. So stay tuned. At the end of this video, we'll move on to the next video, which will be friction and static particles. Try and get that out. Anyway, see you in the next one.